Alrighty, Trig application day uno. We'll do trace days, 3 days of Trig application. So you're going to need your calculators here. We're going to do a lot of wonderful calculations along with it and work through how to plug it in and which trig function to use and all that good stuff. Alright, so we can find missing sides and we can also find missing angles using trigonometry, which is super helpful in real life. Let us begin. Alright, so we've got the Quarry Skateboard Park is installing a new ramp. The dimensions of that ramp are 8 feet, which is the height, 15 feet, which is the length along the water, and 17 feet, which is the length of the ramp that you ride up. There's a typo there, we'll just go ahead and scribble that out. What is the length of incline, the angle of incline? And that's the angle that the ramp would make with the water. So we'll probably want to draw a picture here. I'm gonna make this a little bit smaller so we got some room to work. Okay, let's draw ourselves a little picture. So this would be my water here that the ramp is on. Alright, so this is my angle we're talking about. So 8 is my height, 15 is along the water, and 17 is the ramp that we're riding up. Alright, so from yesterday we know our SOHCAHTOA, right? SOHCAHTOA. So if we're looking at our trig ratios with respect to the angle that we have, angle theta right here, sine of theta is equal to 8 over 17, right? This is my opposite, this is my adjacent, this is my hypotenuse. There we go. Now, cosine of theta is equal to 15 over 17. And last, we got our tangent, which is equal to 8 over 15. All right, so these are my trig ratios, right? Well, awesome, wonderful, but I want to solve for the angle, right? I want theta out of there. Well, how the heck do I get theta out of my trig function? It's not as simple as division or, multiplication or subtraction or addition, right? If I'm thinking of like solving a regular algebra equation, like if I had 2x is equal to 10, how do I solve for x? Well, I would just do the inverse of multiplication, which is division, right? And I'd get x equals 5. So that's my basic, algebra solving of an equation. But we're expanding upon that. So how do I undo sine or undo cosine or undo tangent? Well, if you guys look at your calculators, all right, if you look at your calculators, you will see a sine inverse, then a little -1. You'll also see a cosine inverse, and you'll also, there we go, you'll also see a tangent inverse, okay? If you hit the second and then your trig function, you'll see that. All right, well, what does that do? Well, if I take the sine inverse of this side and the sine inverse of this side, these guys are inverse operations of each other. They're inverse functions, right? So they undo each other. Then I would take the sine inverse of 8 over 17. So I'd plug this into my calculator and I would end up with 28.0724 blah 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 07 degrees. This is my angle that the ramp makes, or the angle of the ramp that it makes with the water. Okay, so I used inverse trig to solve for my angle to get rid of the sine and get that theta out of it. Okay, get that theta out of that trig function so I could get theta by itself. Well, whatever I do to one side, I have to do to the other. So I have to take the sine inverse of my other side. So sine inverse of 8 over 17 is equal to 28.07. I can do the same thing with any one of these. Okay, so I could do the cosine inverse of this side, which means I have to do the cosine inverse of 15 over 17. Or I could do the tangent inverse. Tangent inverse of this side and tangent inverse of this side. Whoop. And that would then again undo the tangents, undo the cosine. And I would type in tangent of 8 over 15. Any one of those, cosine inverse of 15 over 17, tangent inverse of 8 over 15, any one of those would give me the 28.07. Okay? So some problems we're going to have all the dimensions. Sometimes we're only going to have 2 dimensions, and we can find an angle, right? There's just different situations. But basically, in summation, if you will, let's see if I can make any of this smaller. Oh boy, I don't know if I can. Basically what we want to say here is if you're solving for a side, regular trig. Solve for angle, inverse trig. All right, I would jot those 2 things down right here. That's important. Solving for a side, regular trig. Solving for an angle, inverse trig. We're going to practice with that on a couple more problems. All right, we got Little Yachty is ordering a new sail for his little yachty, but needs to figure out how tall the mast is before he orders it. If he is 12 feet from the mast and the angle of elevation from him to the top of the mast is 77 degrees, he uses his phone level to figure it out, you know what I'm saying? How tall is the mast? So let's draw a picture of this situation. So you have your, he's got his little boat, his little yachty, right? And then he's got a mast going up, and he is 12 feet from it, and the angle of elevation to the top is 77 degrees, right? That's what this angle is right here. And let's just hope that that mast is going straight up so it's a right angle. I'm going to assume that, yeah. All right. Well, he wants to figure out how tall it is, meaning he wants to figure this out. So he's looking to find a length, which means we want to use regular trig. So this right here, from with respect to the angle, the x is my opposite side, the 12 is my adjacent side, right? So what uses opposite over adjacent? That's tangent. So the tangent of my angle is equal to my opposite, which is x, over my adjacent, which is 12. So how do I solve this algebraically? Well, I can get rid of the 12 by multiplying by 12 on both sides. Yay! So that's gone. And I'm left with 12 times the tangent of 77 equals x. So at this point, I can just plug this in my calculator, right? So I can do the tangent of 77 times 12. And I get x equals 51.9777, and so on and so forth, right? Bunch of dots. So we'll call it x equals 52 feet. All right. And that'll be a rough estimate, right? It's rounded, so I'll do the squiggly equals. But that is my wonderful height of the mast. Now he knows what he should order for that sail. Okay? So this, since we were solving for a length, we used regular trig. Yay! All right, Tony Hawk is building a skate park in his backyard. He wants to build a ramp that is 6 feet tall and has a 21-degree incline. He has 15 feet, or he has a 15-foot long space to place the ramp. Will it fit? Okay, so he's got this ramp. I'm going to draw a picture here. He's got this ramp that he wants to build. The angle of incline is 21 degrees. Okay, that's that angle. And it's 6 feet tall. He's got 15 feet, right? 15 feet space to put this. He wants to know, is it going to fit? So this essentially is our unknown. We want to know how long is it, right? Is it going to fit in that 15-foot space? Let's find out. Well, if I've got my angle of 21 degrees, I got my height of 6, and I've got the x there. Well, this, with respect to my angle, is my opposite side. This is my adjacent side. Once again, we're using tangent. So tangent of 21 degrees is equal to my opposite, which is 6, over my adjacent x. So how do I solve for x? Well, first, I got to get x out of the denominator. This is a little bit trickier algebra than compared to the last one. So I got to multiply by x on both sides. All right, so that cancels, and I'm left with x times the tangent of 21 is equal to 6. Now, how do I solve for x? Well, tangent of 21, if you were to type that in your calculator, tangent of 21 is just a number. It's 0.3838640, blah, blah, blah. It's just a number. Well, if I had something times x, like a number times x, how would I get rid of that number? I would just divide by it. So divide by tangent of 21. Okay, that's gone, and I'm left with x is equal to 6 over tangent of 21. Now I can just type that in my calculator. So 6 divided by the tangent of 21. And that's going to give me 15.63 feet. Looks like it ain't going to fit. All right, so with the particular information that he has right here, 6 feet tall, 21-degree incline, it's going to be just too big to fit in that space. So, I mean, what could he do? Let's think about this for a second. So first off, our answer is no. What could he do to adjust it? Well, I'm thinking we could probably make it a little bit shorter, right? Instead of 6 feet tall, maybe a little bit shorter than that. That'll make the ramp a little bit smaller and take up a little less space. Could he change the angle? Would he make the angle bigger or smaller? And if you answered a larger angle, right, like 22 or 23 degrees, yeah, that could probably help out. Yeah, you know, you could test that out right now. We could say, hey, what's the tangent, or 6 divided by the tangent of, how about 23? Hey, if it was a 23-degree angle, it'd fit. It'd only be like a little over 14 feet. Or if it was 22 degrees. A 22-degree angle would allow it to fit, so a little bit steeper, it'd be under 15 feet, it would work out. So there's some adjustments that he could make if he'd like. Alrighty, two-part problem here. We got part one. What is the degree pitch of an 11-12 roof? And how could this degree measure be helpful in the context of like a construction site? All right, and the second one is like the reverse. We'll deal with that in a second. All right, so again, there's a little bit of lingo in here that some of you might not be familiar with, some of you might be. So let's fill in the gaps there. Well, when we're talking about pitch, pitch is really just referring to slope. Okay, so the slope of the roof. So what is the degree pitch of an 11-12 roof? Well, that means that my roof is going every 11 feet it goes up, it goes 12 feet over. Or every 11 inches it goes up, it goes 12 over. All right, it's just your slope. It says, what is the degree, right? We're looking for the degree pitch. So I'm going to draw this as maybe a little more of a familiar right triangle, right? So as we go over, rise over run, right? Slope is rise over run, so we go up 11 and we go over 12. What is my degree pitch? I'm looking for this guy right there. All right, so I've just got to flip the triangle over, or rotated it really. So, because I could have made this into a triangle right there. All right. So what is my degree measure? Well, if I'm looking for a degree, an angle, I'm going to use inverse trigonometry. Well, I've got myself here, with respect to the angle theta, this is my opposite and this is my adjacent, which means I'm using tangent. So the tangent inverse of 11 over 12, right? I don't have to set up as like tangent of theta is 11 over 12 and then do all the algebra. I can just set up like this right away because I know if I'm solving for an angle, I'm going to use inverse trig. So when I take my tangent inverse of 11 over 12, I can type it in my calculator just like that. I'm going to get about a 42.5 degree pitch. So 42.51. We'll say 42.5 degrees. All right. Well, how would that be helpful? Well, any of you that have ever built something before, maybe used what's called a miter saw, you can set your degree on that and make the proper cut with it. So it'd tell you the degree that you need to cut that at, right? That angle that you need to make. All right, so a follow-up question is, if a roof has a pitch of 26.6 degrees, what is the pitch in the context of construction? Well, we're going to basically reverse engineer this. I know the degree is 26.6, right? Now, I know it's something over 12, so rise over run. So it's something over 12, which is my opposite over my adjacent, right? So my opposite is my x, my adjacent would be 12. I can solve using trig. So tangent of 26.6 is equal to x over 12. And I'm just going to go ahead and multiply by 12 on both sides and type that bad boy in my calculator. So when I do that, 26.6 degrees, I get 6.009 blah, 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 blah. So that would mean it is a 6/12 pitch. Woo! Wonderful. All right, we got 2 more days worth of this excellent trigonometry, right triangle trigonometry, math awesomeness. So hold tight there, ladies and gentlemen. It's going to be exciting. H-dubs from the book. Woo woo!